Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back again to my lecture video. Okay, today we are going to learn a new topic, which is moment of inertia. So what is moment of inertia? To make it simple, moment of inertia is about the resistance of bending. Bending. So let's take a look at this plastic ruler here. Okay, when we want to bend this ruler here, it is very easy for us to bend it like this. Okay. However, it is very difficult for us to bend like this. Very hard. Okay, difficult. Okay. So the moment of inertia here will show you whether it is easy for us to bend in this direction or in this direction. Okay. So this ruler here has a rectangle shape. Okay. For a rectangle shape, so please refer to this table here. This one here. Okay. For a rectangle, to calculate the moment of inertia, we will use this equation. Okay. Ix bar and also Iy bar. So what is Ix bar? Ix bar is the moment of inertia about x axis. So means that when we want to, this one, okay, rotate like this in x axis. So this one lah. Bend like this, bend like this in x-axis. Okay, and for Iy bar is the moment of inertia about y-axis. So when we want to rotate like this, this one, okay, the difficult one, okay, this one, okay, and B here represents the length of this base here, and H is the height of this rectangle lah. Okay. And then, for a different shape like triangle, semicircle and also a circle, the equation will be different. Okay, so the Ix bar for a rectangle is this one, 1 over 12 BH cube. And for a triangle is different, 1 over 36 BH cube. So therefore, when we want to calculate the moment of inertia, make sure we choose the correct equation to calculate. Okay, so let's try to calculate moment of inertia for this rectangle. Okay, for this ni lah plastic ruler here. Let's say the value of B here is 2 cm. Okay, and then the height H here, let's say because it is very thin, so let's assume it is 0.01. Okay, 0.01 cm. So let's take a look at the value of Ix and Iy. Okay guys, when we calculate the value of Ix and Iy, it is very clear, okay, that the value of Ix is relatively small compared to Iy here. Okay, Iy is very big. So means that it is very hard for us to rotate in y direction. Okay, correct? Very difficult for us to rotate like this. However, it is very easy for us to rotate or to bend it in x direction like this. Okay, so means that the higher the value means that the harder it is to bend or to rotate. Okay, so this is for a common area. So what if we have this kind of area where we have a square, we have a rectangle and we have a triangle? How to calculate the moment of inertia? Okay, so when we want to calculate in this kind of situation here, we have two types of calculation. Okay, the first one is when we want to calculate about x-axis or y-axis. Okay, the other one is when we want to calculate the moment of inertia about the centroidal axis. What is centroidal axis? Centroidal axis is the axis that goes through the centroid of this whole area. Okay, so the centroid of this whole area is located here. So this is the centroidal axis x prime, and this is the centroidal axis y prime. Okay, so let me show you the equation to calculate moment of inertia about x or y axis and moment of inertia about centroidal X and Y axis. Okay everyone, so these are the equations to calculate moment of inertia. The first one is about X or Y axis, and the second one is about centroidal X or Y axis. So what's the difference between these two? Okay, for about X and Y axis, as I explained before, we want to calculate moment of inertia when we want to rotate about this X or Y axis. Okay, and for this one here, centroidal here means that when we want to rotate about this X prime axis and also this Y prime axis. Okay, the total of moment of inertia, okay, for this one Ix here, okay, for this whole area here is the summation of this one. Okay, summation of this one. So this one here refers to the summation of this one for the square, and this one for the rectangle, and also for the triangle. So we need to calculate it one by one, and then we total up everything. Okay, so what is this Ix bar here? So Ix bar here is this one. Okay, the value from the table. So when we want to calculate Ix bar plus AY with square here, for this for this square here, we will refer to this shape, which is this one. So we will use Ix bar is 1 over 12 BH cube. Okay, and A here is the area, okay, for the square, which is this one times this one. And then Y wave. So what is Y wave? Y wave here is this one, the location of the centroid. This one. Okay, the centroid of this square here, this one here, is this one, Y wave. This one, Y wave. Which is why we want to use Y wave and then times, Y wave square. Okay, don't forget this square. Okay, and then when we want to find Iy is the summation of Iy bar plus Ax wave square for all the shape here. Okay, this one plus this one, and then plus this one. Okay, and then same goes with the about centroidal X or Y axis here. Okay, this one X prime and also Y prime here. The difference here is this one. Okay, so what is this one? Okay, this one here, okay, this Y bar here refers to this one. Okay, the centroid here, the centroid for the whole area, this one. Okay, so C here is actually X bar, Y bar. Okay, and this Y wave here, okay, Y wave here is the value of the centroid for the common shape. Okay, this one, okay, the value here. So means that this one here is Y bar, and then we need to minus with this Y wave. Okay, and same goes with this one, I Y prime here. Okay, moment of inertia about centroidal Y axis. Okay, so the X bar here represents the centroid of the centroid X for the whole area minus the centroid for each common shape. Okay, so in the next lecture, I'm going to show you on how to calculate the moment of inertia about X and Y axis, and in another video, I will show you on how to calculate about the centroidal X and Y axis. Okay, so please stay tuned and please watch my next video. See you again later. Bye bye.